Okay, there is a one important point. If you're just going to use the energy equation or momentum equation, that we need to just clarify. So one thing very important, once we have like a non-uniform distribution of the velocity, for example, this is a cross-section of the pipe. This is the pipe, for example. This is a cross-section, and this is the distribution of the velocity all over the this kind of like the diameter of the pipe. You can see here the velocity at the the middle is the maximum velocity. Once you're just going to approach the sides of the pipe, the velocity becomes like the very decreasing and eventually becomes like the zero. So to just allow this kind of like the non-uniform distribution of the velocity within the context, some coefficients are introduced for the both energy equation and also for Bernoulli's and momentum and Bernoulli's equation. For energy equation, alpha is used as a and used as a coefficient of the velocity head. So alpha v squared over 2g for if it applies for like the beginning and the end is not the same pipe. So probably you need to just use like the alpha 1 and alpha 2 to just calculate that one. So if you're just going to have like a Bernoulli's equation ZA, so V2 or the energy or so the velocity term or the velocity head needs to be just multiplied by alpha. Alpha A or times VA squared over 2G plus PA is the pressure head over rho G is the same. So the only difference is that you can see the alpha to the left and right are calculated. So we're just going to use, by the way, the average velocity. Why? So for example, if you're just going to use the continuity equation, if you remember continuity equation, Q is equal to VA. And if you're just going to calculate the V, or whatever we're just going to use, that one is here is called average V. So all the time we're just going to calculate the average V. Let's say there is some sort of like the line like this one. If you're just going to take the average of this one and this one, it will be somewhere in here. So imagine this is the average V or the V average. Oh, sorry, this is the V, which is the average. Okay, so this is the average velocity, and the same for momentum equation. If you're just going to use the non-uniform distribution of velocity within the across the pipe, you can use the beta coefficient. Beta coefficient is like the F is rho Q beta 2 V2 minus beta 1 V1. So this is like the beta. And how we can calculate this kind of like the coefficients alpha and beta. So normally the references, they provide with the different types of the flow regime that we will discuss it later in this session. If like the flow is like a laminar in the pipes, it's going to be like the up to 2. For the turbulent situation that we will discuss later, it's just going to be like a close to 1. And for natural flow and natural stream, like the alpha is just going to change like within these ranges. So all of them ranges between 1 and up to 2. And the same for beta is going to be like between 1 and 1.33. And just bear in mind, if you don't have any detailed information, you can assume all the coefficients of alpha and beta, both of them are equal to 1. Okay, but if you have more information, you can use any of these coefficients as you like. So just bear in mind, we just learned the total head in 3 terms: Z, V2 squared over 2G, and P over rho G as total head. Just bear in mind the piezometric head that we can calculate it by using the piezometer or the standing pipe to calculate the pressure head. So it has got like the 2 elements or the 2 terms, elevation head and the pressure head. So this normally shows the pressure head, but if you're just going to have like a constant the elevation head relative to the reference line, we can say this is the piezometric head. Okay, so that's like a total head as well. And just bear in mind, if you remember earlier, we said that all of these 3 terms are expressed in like in units of meters, so above the meters actually. So you're just going to see here Z is exactly M, and V2 over 2G, the dimensional analysis, we can just kind of do it here. Velocity is like a meter per second raised to the power 2 times to G is at the denominator, is a meter per square second, meter at the bottom and a square second at the top. And if you're just going to cancel this one, and this one, completely cancel, and this one will be canceled with this one. And what is left is M. And for the last one is like a P over rho G. So this is like the rho G or the W in the like the small or lowercase w in the reference book. So the P is a pressure, is Newton per square meter, and W is a rho G by the way. So the rho G, the units is Newton per cubic meter, or you can just easily use the units of the rho and units of the G. It's very simple and straightforward. And if you're just going to use the units of the rho is like the kilogram per cubic meter, and the G is like the meter per square second. But if you remember, we had the like that, but here we're just going to use the Newton per cubic meter. So how we can just gonna get that one? So I'm just gonna write it in this way. So rho G, so is equal to the units is rho is a kilogram, so as you know here, per cubic meter. So the G is meter per square second. Okay, so this one we can say is cancelled out with this one. We're just gonna write it in meter square. So whatever we have is the kilogram meter square over the second square. So if you're just gonna simplify this one by using this, F is equal to MA, second law of the Newton, remember? You can easily, or the W is equal to mg. Okay, so you can see how we can convert. This is like the, and the left hand side is the newtons, and the right hand side the units is like a kilogram times meter per square second. And you can just take some sort of like the relationship between the kilogram, meter, and second unit on the right hand side and the newtons on the left hand side. You can easily substitute that one from this connecting relationship in here to here, and you will get to this kind of like a formula. Please just do this one and practice. I will show you later on how we can just get this point. Okay, so this is the energy coefficient and the momentum coefficient.